Yeah, okay, guys. Now here we want to look at some of these equations, these trig equations that we got, which I found very intriguing. Okay, and we want to look at how you can confirm your answers using Desmos. Okay, so this equation from our worksheet, as looked at right here. Okay, first order business is whenever you have the argument of the sine or cosine or any of the other trig functions being anything other than x, you'd be well advised to make a substitution. So there we go. We just let u equal 3x minus pi over 4. Then the equation automatically collapses to this expression, sine of u equaling 1, which is, okay, from our graph, as we should well recall, the sine is equal to 1. That's its high point at pi over 2, and all wavelengths down. So u is equal to pi over 2 plus 2 pi k. Now, u, however, is 3x minus pi over 4. Let's not forget that, okay? Um, so what we want to do is solve this new equation, this equation which was resulting from the substitution for x. So what we want to do, of course, is solve this for x. So we add pi over 4 uh, to both sides, getting rid of it over here. But when adding pi over 4 over here, we can only add it to the pi over 2 expression, not to the 2 pi k, because this is multiple wavelengths. So just add it to the pi over 2, which of course, adding pi over 4, a quarter pi to a half pi will give you a 3/4 pi, all right? So that's taken care of, plus the 2 pi k. And, um, and then, of course, to finalize this and solve for x, go and divide by 3. So dividing this expression here by 3 will result in this expression, pi over 4 plus 2 pi over 3k. Now, it should be of no surprise why we get this 2 pi over 3, because, when we looked at earlier at determining the period of this function, then of course we know the period is the normal period, which is 2 pi, divided by b, which is divided by 3, okay? So the adjusted period is 2 pi over 3. And so that's exactly what happens down here. Okay, we get the one hit per cycle, and add all the subsequent cycles. So now we're going to take a look at that expression um, via Desmos, okay? So I'm going to Desmos, and we'll show you a few little things on Desmos here as well. Okay, so we're going to key this in. Function is, we get the sine from the function menu here. It is sine of uh, 3, what was it, 3x minus pi over 4. I believe that's what, and pi is entered as pi. Well, I thought it was entered that way. Let's get that again. Okay, so that's uh, pi divide by 4. Okay, so here's our graph. All right, let's just me double check. I'm thinking that's what 3x minus pi over 4. Yeah, 3x minus pi over 4. And where is that equaling 1? Where is that equaling 1? That's the question that we're asking. Um, so let's go back to our Desmos, do our console on that. So 3 pi, this is the graph. Where is that equal to 1? Well, we'll draw the horizontal line y equals 1 here. And of course, doing that, you can just see where they meet. Okay, and here it is. Here's the point. There it is. I point right to it. Click on this. I point right to it. There it is. The pi over 4. What's the next hit? Well, that would be one wavelength down the line. So that would be 11 pi over 2. And we could validate that 11 pi over 2 was pi over 4 plus 2/3 of pi. Let's just kind of do that for you here quickly, and move to another problem. So we knew pi over 4. So pi over 4 plus 2 pi over 3. Of course, just with fractions, need a common denominator. That would be 12. And so this would go jump up to 3 pi over 12. And then this, of course, would jump up to, um, 8 pi. All right. So when we add those, we get 11 pi over 12. 11 pi over 12. And let's just say when we subtract them, what do we get? We get negative 5 pi over 12. So, and that should have been a hit there as well. Let's go back and confirm that. Okay. So here's your hit. Here's your hit the next time down the line. 11 pi over 12. That's what we said it would be. This should be the negative 5 pi over 12. Sure enough, it is. Okay. So that's kind of validating that our solutions are correct. We're incorporating the Desmos, the nice trig graphing features of Desmos, okay, to help us out there. All right. Um, One other thing, maybe just as a looking at Desmos here, okay, up here in this little wrenches tool, click on that, and we get an option here to offset our axes. So our axes are running from negative 10 to 10 with probably with no designated step there. But what we can do, which is nice, is we can put this thing in terms of pi, all right, uh, which is kind of nice. So we know that we know that we're phase shifted by what? Well, we're phase shifted again by c over b, so that should be pi over 4 and pi over 4 divided by 3, so that should be pi over 12. So I'm going to actually I'm going to put this in with a to show the increments of pi over 12 for beginners. Okay, so again, pi divide 12, and then I'm going to just do our normal. Well, I think I can just go from pi negative pi to positive pi, and we get a pretty good view of this function. Okay, so here we go. Put that in as pi pi. Okay, here we go. All right, it's going to default to radians. Here we are. Okay, this is our first intercept, which again is pi over 12. That's reflecting our translation, our horizontal or phase shift of pi over 12 units to the right. Okay, and then our hits once per cycle, pi over 4, and all wavelengths down the line, all wavelengths being 2 pi over 3. Okay, so nice stuff there with Desmos to help out with these intriguing, yes, no pun on words there, intriguing trig equations. Okay, so we're going to show you a little bit more with some subsequent videos. Okay, so get to work on those. All right, great.